Welcome to the deep dive. Today, we're tackling blockchain technology.
Right.
Now, if that word makes your eyes glaze over a bit, well, you're definitely not alone. It can sometimes feel like trying to understand, I don't know, the science behind the universe or something.
It definitely has that reputation, doesn't it? A kind of mystique. But, underneath all that, the basic ideas are actually pretty elegant and really impactful.
And that's exactly our goal here today. We've gone through, well, a lot of information, a lot of sources, to pull out the crucial bits for you.
Mm-hmm.
What blockchain really is, why it actually matters, and why it looks like it's going to be more than just another tech buzzword.
Yeah. Our mission, if you like, is to make it clear, make it understandable.
Hopefully without needing a PhD in computer science to get it.
Exactly. We'll cover everything from the basic definitions right through to how it's starting to pop up in all sorts of different industries.
We'll be guiding you through pulling out the key stuff from what we've read and trying to connect the dots so it all makes sense.
And one really big dot we need to connect is that whole blockchain versus Bitcoin thing.
Oh yeah, that causes so much confusion for people starting out. We'll definitely clear that up.
We will.
Okay, so let's dive right in then. At its simplest, maybe the simplest possible terms, what is blockchain?
Okay, so at its absolute core, blockchain is really about enabling fast, secure, and transparent ways for people to exchange digital value.
Value like money or other things.
Both, actually. Could be digital currency, absolutely, but it could also be data, any kind of digital information. And the key is doing it peer-to-peer.
Peer-to-peer meaning without a middleman.
Exactly, without needing someone like a bank or PayPal or some other central authority overseeing things.
Okay, so how does it manage that kind of digital handshake without someone in charge?
Well, think of it like a shared digital notebook or maybe a ledger. One source we looked at had a pretty good analogy. Imagine an Excel spreadsheet. But this spreadsheet isn't just on one computer. It's copied and distributed across maybe thousands of computers, all networked together. These computers are called nodes.
Got it. So like everyone on this network has their own identical copy of this spreadsheet, this ledger.
Exactly, and it's constantly being updated.
So what happens when, say, a new transaction needs to be recorded?
Right, so when new information transactions, some data needs to be added, it gets packaged up and broadcast out to that whole network.
To all the nodes.
To all the nodes, and then pretty much automatically every single computer updates its copy of the spreadsheet to include that new entry. It keeps everyone synchronized.
And that sharing, that synchronization, that's tied to the security somehow.
Absolutely. That leads right into the security aspect. Our sources really stress how incredibly difficult it is to hack a blockchain.
Why is it so tough for, the bad guys?
Well, it really boils down to cryptography. Strong mathematical coding. Each chunk of data, each block is sealed, essentially. So, to mess with the record, a hacker can't just break into one central database like they might normally try to do.
Because there isn't one central database.
Precisely. They'd have to somehow attack and change the data on more than half of all those computers, all those nodes across the whole network, basically all at the same time.
Wow. Okay, the coordination alone sounds...
Almost impossible. The scale makes it incredibly secure.
Right. That paints a really clear picture of why it's so resilient.
Yeah.
Okay, let's tackle that big one. Blockchain and Bitcoin. What's the real connection there?
Yeah, this is super important to get right. Our sources are very clear on this. Bitcoin is a digital currency. Blockchain is the underlying technology that makes Bitcoin possible.
Okay.
Think of it like this, maybe. Blockchain is the operating system, like iOS on your phone or Windows on your PC. And Bitcoin is just one app, one program that can run on that operating system. A very famous one, obviously, but still just one application.
That's a great way to put it. An OS and an app. So Bitcoin, the app. What problem was it originally trying to solve?
Bitcoin was really designed as a way for people to store value and send it directly to each other peer-to-peer without needing the usual financial go-betweens.
Like banks or payment processors.
Exactly, cutting them out. The idea was to create a decentralized digital cash system.
And the specific blockchain for Bitcoin, what does that ledger track? Is it just Bitcoin stuff?
Yes, the Bitcoin blockchain is a very specific ledger. It only records Bitcoin transactions, nothing else. But just like the general concept, it's not stored in one place.
It's distributed across that network of computers.
Right. A global network, all holding a copy of the Bitcoin transaction history.
So how do new Bitcoin transactions get added? You hear about mining all the time. What's that about?
Right, mining. So for a new transaction to become official, to get added to that ledger, the network of computers, the nodes, they all have to agree it's valid.
They reach a consensus.
Exactly. That agreement is called consensus. Mining is the process, the work involved in reaching that consensus. Miners use a lot of computing power to solve these really complex cryptographic puzzles. And the first one to solve the puzzle gets to basically validate a batch of recent transactions, bundle them into a new block, and add it to the existing chain.
And they get paid for that.
Yep, they're usually rewarded with some newly created Bitcoin for their effort. That's the incentive.
Okay, and how does this whole consensus thing stop someone from, say, spending Bitcoin they don't actually have? Or spending the same Bitcoin twice? I think one source used a Tom and Ben example.
Ah, yes, the double spending problem. That's absolutely crucial. So imagine Tom wants to send, say, 10 Bitcoin to Ben.
Okay.
But, Tom secretly only has 5 Bitcoin in his wallet. Before that transaction ever gets confirmed and added to the blockchain,
The whole network checks.
the entire network checks Tom's history on the ledger. They see he doesn't actually have 10 Bitcoin to send.
So they reject it.
Exactly. The network reaches consensus that the transaction is invalid and it's never added to the chain. That verification step prevents anyone from spending coins they don't have or trying to spend the same coins multiple times.
That makes sense. A built-in fraud prevention mechanism, basically.
Got it.
Okay, so the foundations are making sense. Now, let's get a bit deeper into the mechanics. How does blockchain actually work day to day? Our sources drew some interesting comparisons with, like, how we normally share documents.
Yeah, think about working on a Word doc, maybe on a shared drive. Often, only one person can edit it at a time, right?
Right, where you end up with multiple versions, V1, V2, V2 final, really.
Exactly. And there's always that risk. What if the central server where it's stored goes down? You could lose stuff. It's quite sequential, quite centralized.
Like passing a digital baton, yeah. How's blockchain different?
It's a totally different way of thinking. With blockchain, if you have the right permissions, you can essentially see the document, the ledger, and any changes happening almost in real time.
So everyone sees the same thing at the same time.
Pretty much. It's a shared, secure environment. The data isn't locked down by one person or one company sequentially. It's simultaneously viewable and verifiable by many.
And because it's spread out everywhere, it's much harder to break or lose.
Absolutely. That distributed nature makes it incredibly resilient. There's no single point of failure. If your computer crashes or my computer crashes,
The network keeps going. The data's still there on all the others.
precisely, big reduction in risk compared to storing everything in one central place.
Okay, now, our sources kept bringing up these things called hashes. What are they? What do they do?
Right, hashes. Think of a hash as a unique digital fingerprint. It's a string of letters and numbers, an alphanumeric code that's generated for every single block of data added to the chain.
A unique fingerprint for each block.
Exactly. But here's the really clever part. Each new block doesn't just contain its own unique hash. It also contains the hash of the block that came immediately before it in the chain.
Ah, so they're linked.
They're cryptographically linked. It creates this chain, hence blockchain, where each block essentially points back to and confirms the integrity of the previous one.
So if someone tried to tamper with an old block,
Bingo. If you tried to change anything in an older block, even one tiny character, its fingerprint would completely change.
and it wouldn't match the hash stored in the next block anymore.
Correct. The chain would be visibly broken. The entire network would immediately know that something's wrong, that tampering has occurred. It makes the history incredibly secure and tamper-proof. It's like a self-checking digital history book.
Wow. Okay, so each link confirms the one before. And this keeps coming back to decentralization. Can you just sort of hammer home why that's such a big deal?
Decentralization just fundamentally means there's no single boss, no one company, no government, no single entity owns or controls the whole blockchain.
It's run by the network.
It's run by the network of participants, those nodes we talked about. It's a distributed ledger. This lack of a central point of control is really the source of its security, its transparency, its resilience. Power is spread out.
And the consensus mechanism, that's like the rule book everyone on the network agrees to play by.
That's a great way to put it. Yeah, the consensus mechanism is the specific set of rules the network uses to agree on whether new transactions are valid before they get added to the chain.
Making sure everyone's on the same page, ledger-wise.
Exactly. It ensures the integrity and consistency of the record across the entire distributed network.
We also heard about smart contracts. Sounds a bit sci-fi. What are they?
They're pretty cool, actually. Smart contracts are basically just pieces of code, computer programs that live directly on the blockchain.
Okay. What do they do?
They automatically execute the terms of an agreement once certain conditions are met. No human intervention needed.
Can you give an example?
Sure. Imagine an insurance policy for flight delays. A smart contract could be linked to a reliable flight data feed. If the feed shows your flight is delayed by, say, over 3 hours, the condition is met, the smart contract could automatically trigger and send the insurance payout to your digital wallet.
Wow, okay, no claim forms, no waiting.
Potentially, yes. It automates verification and enforcement, cutting out intermediaries and potential disputes.
Very efficient. And the last key piece seems to be immutability.
Yeah.
Once it's on the blockchain, it's there forever. No edits, no deletes.
That's the idea. Once a transaction is verified by consensus put into a block, and that block is linked to the chain with those hashes, it's essentially permanent, unalterable.
A one-way street.
Exactly. You can't go back and change the past records. This immutability is fundamental to why people trust the blockchain. It creates that reliable, transparent, auditable history.
Okay, so putting all these features together, decentralization, cryptography, consensus, immutability, it definitely creates some powerful advantages. Let's walk through the main benefits our sources highlighted.
Yeah, absolutely. The first big one, as we said, is decentralization. No central server, no middleman, which often means lower fees, and no single point of control or failure.
And that leads to what some called unbreakability.
Yeah. Because the transactions are cryptographically sealed and need that network consensus to be changed, it's incredibly hard to break or tamper with. It's very robust.
Then there's trust and transparency.
Right. Because it's often a shared, sometimes even public database, the details of transactions, when, where, how much can be visible to participants. This openness builds trust, much more transparent than many traditional systems where things happen behind closed doors.
It also seemed much more cost-effective in many cases.
Definitely. Taking out those intermediaries, banks, brokers, processors can slash transaction costs and overhead for businesses.
And dramatically faster operations. That international payment example was striking.
Yeah, that's a classic one. Traditional international bank transfers can take, 3 to 5 days, sometimes longer, and have hefty fees. Blockchain payments can potentially happen in minutes or even seconds, and often for a fraction of the cost, a huge difference.
The availability aspect also stood out.
Because it's distributed, the network doesn't go down if one or even many computers have problems. It keeps running. Think about that hospital example again. If their central server fails, chaos. A distributed ledger avoids that vulnerability, high availability.
And it can make life easier for businesses working together.
For sure. If you have two companies with totally different internal systems trying to share data, it can be messy. A shared blockchain can act as that single, trusted source of truth between them, making collaboration and data sharing much smoother.
And just to recap the security angle.
It's multi-layered, right? You've got the cryptography protecting the data, the hashing linking the blocks, the consensus making sure only valid stuff gets added, and the distribution, meaning there's no single honeypot for attackers. Much more secure in many ways.
Which should lead to improved accuracy as well.
Yeah, fewer errors. It's a single transparent ledger. Records are chronological, immutable. Verification is done objectively by the network rules, not subjective human judgment. Reduces mistakes and disputes.
And finally, overall higher efficiency.
Streamlined processes, fewer bottlenecks, automation through those smart contracts we mentioned. It all adds up to making operations run more smoothly and efficiently.
Okay, that's a compelling list of benefits. Let's look at some real-world examples our sources gave. Identity management seems like a big one.
It really is. Think about how our identity works now. Separate logins for everything, all storing our data on their central servers.
Like Netflix, Facebook, work accounts.
Exactly. And those servers are prime targets for hackers. The Equifax breach was mentioned, hundreds of millions affected. Blockchain offers a different model.
Decentralized identity.
Potentially, yes, where you control your own identity data, perhaps stored decentrally, and grant access as needed. No single massive database for hackers to steal. Much more user-centric and secure.
Banking and payments, we touched on that. But the potential seems huge.
Massive, especially for the unbanked billions of people worldwide without access to traditional financial services. Blockchain could provide a way in.
And for existing banks.
Faster, cheaper transactions, like we said. Accenture estimated big investment banks could save over $10 billion a year using blockchain for clearing and settlement. That's serious money.
The energy sector was another interesting one. How does blockchain fit in there?
It allows for a more dynamic grid.
Eh.
Imagine you have solar panels on your roof. Normally, you sell excess power back to the big utility company. With blockchain, you could potentially sell that excess power directly to your neighbor who needs it.
Peer-to-peer energy trading.
Exactly. In near real time, maybe at a better price for both of you, cutting out the middleman. Blockchain provides the secure ledger to track those microtransactions. It facilitates local energy markets and helps integrate renewables better.
And the list of industries exploring this just goes on and on, doesn't it?
It really does. Our sources mention cybersecurity, education, things secure, digital diplomas, marketing, advertising, definitely supply chain management for tracking goods from source to consumer.
If government's looking at it for voting, maybe.
Yeah, potentially more transparent and audible voting. Music and video for rights management, e-commerce, healthcare for secure patient records or automating insurance claims.
Logistics, NFTs for digital ownership, insurance fraud prevention, retail transparency, real estate titles.
The applications are incredibly diverse. It's really about finding processes where trust, transparency, and security are paramount, and where removing intermediaries can add value.
But it's not all smooth sailing. We need a balanced view. What are the main challenges or downsides our sources pointed out?
Good point. It's not a magic bullet. One major challenge is transaction limitations or speed.
Bottlenecks.
Yeah, sometimes. As networks get busier, some blockchains, especially older designs, can struggle to process lots of transactions quickly and cheaply. Fees can go up, waits can get longer.
And the energy consumption issue.
Yeah.
That gets a lot of headlines, especially with Bitcoin.
It does. Particularly the proof-of-work system that Bitcoin uses requires immense amounts of electricity. That raises valid environmental concerns and questions about long-term sustainability for that type of blockchain. Newer consensus methods are often much more energy efficient, though.
And there are general scalability issues.
Kind of related to the speed issue. If every single computer node has to store the entire blockchain history and process every transaction, the network can get slow and clogged up, especially when lots of people are trying to use it. Finding ways to scale effectively is a big area of research.
And finally, regulation. The Wild West feeling.
A bit, yeah. Governments globally are still figuring out how to regulate this stuff. Is it a currency, a commodity, something else? That lack of legal clarity can make businesses hesitant to fully jump in and can slow down wider market adoption.
It also seems like there are different types of blockchain. It's not just one kind fits all.
Correct. Our sources outlined a few main types. There are public blockchains like Bitcoin or Ethereum. Anyone can join, anyone can view the ledger, fully decentralized, permissionless.
Okay.
Then you have private blockchains. These are permissioned. You need an invitation to join. They're usually controlled by a single organization, like a company using it for internal record keeping. Offers more privacy and control. There are also consortium blockchains. These are also permissioned, but they're run by a group of organizations, maybe competitors in an industry, working together on a shared platform. They share control.
Interesting.
And finally, hybrid blockchains, which try to combine elements of both public and private. Maybe some data is public, some is restricted. A mix and match approach.
It's interesting to see how this technology evolved. It didn't just appear out of nowhere with Bitcoin, right? The ideas go back further.
Oh yeah, much further. Some foundational concepts date back decades. Sources mention David Chaum's work in the early 80s, Ralph Merkel's ideas on hash trees even earlier in the 70s.
And the first actual blockchain-like thing.
That was Stuart Haber and Scott Stornetta back in 1991. They were trying to figure out how to timestamp digital documents so you couldn't tamper with them later. They used cryptographic hashing in a chain. Sound familiar?
Very familiar. And then boom, 2009, Satoshi Nakamoto, Bitcoin.
Exactly. Bitcoin was the breakthrough application. It took those earlier ideas and combined them into the first truly decentralized public blockchain system that actually worked and gained traction, a landmark moment.
And then Ethereum came along in 2015 and really broadened the scope.
Absolutely. Ethereum introduced those smart contracts we talked about. Suddenly, blockchain wasn't just for digital money. You could build all sorts of decentralized applications, dApps on top of it. It opened the floodgates for innovation.
The timeline our sources provided showed just how fast things have moved since then. Quite a roller coaster.
It really has been. From the first Bitcoin transaction, that infamous pizza purchase.
10,000 Bitcoin for 2 pizzas.
Crazy to think now. Reaching parity with the dollar, Market cap milestones, Ethereum's launch, the first NFTs way back in 2014, big companies like IBM getting involved, the huge price swings.
China's changing policies,
Yeah.
institutional players like Backed, PayPal jumping in, central bank digital currencies starting to emerge.
The rise of Web3 concepts, more market volatility, collapses like FTX shaking confidence, increasing regulatory focus. And yeah, those predictions hitting $100,000 Bitcoin in 2024, it's constantly evolving.
So let's just nail this down one last time, the blockchain versus Bitcoin distinction. Super clear.
Okay, simple version. Bitcoin is the specific digital money. Blockchain is the underlying technology, the digital ledger system that Bitcoin runs on. Blockchain is the foundation. Bitcoin is one building built on that foundation.
Got it. And that crypto market volatility we saw in the timeline, what drives those wild swings?
It's a mix of things. New tech developments, definitely. Market sentiment, hype, and fear play a big role. Investor demand, obviously. And increasingly, regulatory news or actions by governments can really move the needle. It's still a relatively young and sometimes speculative market.
One last thing that sounded really cutting edge was integrating blockchain with AI.
Yeah, that's a fascinating area with huge potential. Think about combining blockchain's security and transparency with AI's ability to analyze data and make decisions.
How would that work?
Well, imagine AI optimizing a complex supply chain based on real-time data, while blockchain provides that secure, trustworthy, immutable record of every single step. Or AI detecting financial fraud patterns, with blockchain securing the transactions themselves.
I'll care too.
Could be. AI for diagnostics, blockchain for securing the patient data. The synergy could lead to systems that are smarter, more secure, and more transparent all at once. Lots of possibilities there.
Okay, so as we wrap up this deep dive, what are the absolute key things people should take away about blockchain?
Well, I think the main points are it's a decentralized, distributed ledger. It's designed to be secure and transparent, largely thanks to cryptography and consensus. It's the tech behind Bitcoin, yes, but it's much bigger than just crypto.
It has real advantages, cutting out middlemen, boosting security, improving transparency and efficiency.
Exactly. And that leads to potential uses across tons of industries, way beyond finance. But it also has challenges, speed, scalability, energy use in some cases, and the whole regulation piece is still developing.
So it really feels like it's more than just digital cash. It's a fundamental shift in how we might handle information and trust online.
That's a great way to summarize it. It challenges our reliance on central authorities and opens the door to more direct, secure, peer-to-peer ways of doing things digitally.
So the final thought for you, listening, is maybe this. What does it really mean if we can build systems where trust comes not from a central company or authority, but from the network itself? What new doors could that open? Not just for money, but for potentially everything we do online and beyond. It's worth thinking about which of those applications we discussed really caught your interest. Maybe dig a little deeper there. Thanks for joining us on The Deep Dive.